So before we dive into this introduction to Python curriculum, I want to give you an overview of my bias, where I'm coming from as I'm trying to teach you this information. It's important for you to be thinking about this as you try to get into the world of technology, to realize all instructors are going to have their own biases, they're going to have their own worldviews, they're going to have their own slants, and they're going to try to be pushing you into a particular direction based off of what their needs are, right? So if you go to something like a boot camp program, they may be pushing you very strongly to get things like certification. So they're going to teach you how to test, they're going to teach you how to study, they're going to teach you all those trick words when you go in to do the computer exam, right? So that you can get that piece of paper at the end of the day. So if a piece of paper is going to get you what you need in life, that's a great thing. I will tell you, for many of us, the piece of paper isn't necessarily as valuable as you think it is. So it's important to understand what the bias is of your instructor and the overall program you're in to really understand if it's going to get you where you're going, or if not quite getting you to where you want to be, what you may need to adjust to be able to basically solve your particular problems for your particular situation. The biases generally of Silicon Dojo is we try to keep our lessons simple. Continuing research is required. We're not going to teach you everything in these classes. We're going to try to focus on building something. We're going to try to teach you. You are supposed to learn, not simply listen. And I am coming from this as a technology professional. Now, one of the key concepts with Silicon Dojo, and something that I try to do whenever I'm teaching, is the idea of keeping lessons simple. One of the biggest problems we have with new people trying to get into the world of technology is they get inundated with so much information and they're not able to follow everything that they're being told, that at a certain point their brain just kind of stops working. Basically, the problem that we have is a lot of people actually don't fail to become technology professionals. They just give up, right? They are smart enough, they are talented enough, they could be able to do it, but with so much stuff being dumped on them at one time, they just become overloaded. They don't know what to focus on. Essentially, they're trying to fix problems where there isn't a problem, and they're not looking at a place where there is a problem, and it just becomes a big old disaster. So we try to keep all of our lessons simple. Whenever I'm going to be teaching you something, I'm going to try to teach you a very specific topic and try to keep it as narrow as possible. So many times we are not going to go into areas of security or areas of operating system configurations and all that kind of thing. We are going to be focusing on exactly what the class is focused on so that you understand that specific concept and you don't get lost with all of the extraneous things. My warning for that, though, is that is good for many reasons, but the one warning there is, especially for smart students and students that are able to keep up, is we do skip over a lot of things like security, right? So when we're doing things, and let's say we're interacting with the operating system, we're not going to do things necessarily like sanitization, being able to clean up the commands that go to the operating system initially, because I want to teach you how that works, and then we'll deal with sanitization and that type of stuff later. The issue becomes is if you take our lesson, you immediately put it onto a server on the internet. Bad things might happen. So that's one of the warnings here. Basically, our educational process is to keep everything simple, as narrowly focused as possible so that you understand the subject. So when you come out, you understand that particular subject better, but do realize sometimes some of the extraneous things do get lost in this method, and you have to do more training to be able to figure out those things going forward. So in the same vein as keeping the education simple is that continuing research on your part is going to be required. So many times, in order for an education institution to have a quote-unquote thorough training program, they literally try to teach you everything, which is, 10% of the stuff that you need in life, and then 90% of the stuff that you might see at some point 10 years in the future. Again, to try to make this as fast as possible, to try to actually get you out there building things, we are going to focus on the work that you're most likely going to actually be doing, essentially the 10% of the things. So when we're dealing with functions, when we're dealing with other things, again, like say in the Python world, we will show you the 10%, the things that you are most likely to run into, and we won't necessarily go over a lot of the stuff that becomes a little bit esoteric and you may never have to deal with. So it is going to be important for you to do continuing research. Basically, if I show you how to do something, you're interested in learning more about it, go out onto the internet and do a little bit more research. There's a website called W3 Schools that is absolutely awesome, and ChatGPT is phenomenal for explaining things like functions and different settings within things like programming languages. So do make sure to go out and do additional research beyond what I'm teaching you here. Another key component of Silicon Dojo and how I teach in general is the idea of focus on building something. That we should either try to solve real actual problems or at least simulating solving real and actual problems. The big problem that I see with a lot of people that try to learn technology is that they try to learn this technology, again, basically by rote memorization, but they don't really understand why it's valuable. They don't really understand why it's useful. They don't really understand why they're learning what they're learning, which makes everything so much more difficult. So one of the things that we try to do here is that we actually try to solve problems. We try to simulate solving problems so that you understand what we're trying to accomplish with something like the Python programming language. Now, this is an introduction series, so the fact of the matter is a lot of this is just going to be kind of boring stuff that you have to learn. Additional courses that we will have in the future will get much more specific into the actual solving problems thing. But one of the things I want you to be thinking about as you go through these classes is, as you're learning things, look around and try to figure out a little problem that you might be able to solve. Can you build a little script that can solve some type of problem for you? Because what happens, right, is if you can create a little script that's solving some type of problem for you, that means you get invested in learning Python because now you really understand that it can solve a problem for you. And then if that's able to do a little something, well, then if you learn a little bit more and a little bit more and a little bit more, and what about this and what about this, and all of a sudden it actually becomes a very enjoyable thing to learn Python, and you're going out there and you're actually trying to build things that will hopefully push the ball forward for you. So generally, again, we focus on trying to build something. I will warn you though, with this introduction series, I mean, I got to teach you loops and lists and that kind of stuff. There's only so much practical we can do, but we will try to do that in the series. One of the big things that I want you to be thinking about as you go through this series is, are you learning or are you just listening? One of the complaints that I get as an instructor, having done this online since 2009, is that sometimes I can be a bit verbose. I can talk a lot. Now in this series, the classes are much shorter because we're talking about very specific things, but obviously I can still talk a bit. One of the reasons that I do that, though, is I want you to be learning, not simply to be listening. I have a class online on the YouTube channel called the OSI Model Demystified. Basically, it goes for about 45 minutes. One of the complaints that I get from people is, that's too long. You could say the OSI model in 5 minutes. It's like, yes, but can you teach the OSI model in 5 minutes? That 45-minute class, I have people that have gone all the way through computer science university programs that still do not understand the OSI model. They have taken that class from 12 years ago, and now finally they understand what that model is about. So one of the big things as you go through this program is, I want you to be asking yourself, are you learning the material? Or are you just basically clicking the play button, listening to it, hitting complete, and moving on to the next thing? If all you're doing is listening, you might as well go play video games. That's about as useful as this is going to be. I really want you to focus, and you need to be focused on learning if you actually want to be a technology professional or do this stuff in the real world. In almost every single session that we have, there are going to be examples. I want you to take those examples. I want you to put them into VS Code or your IDE. I want you to see that they run. Then I want you to sit there and tweak them a little bit. Modify them in some fashion to be slightly different so you can start to get the feel of the code. And then beyond that, if you have enough time, basically put that aside and then see if you can write it on your own. Do you remember enough to be able to type these things out so that you really are starting to get an understanding of how Python works? If you understand how this works, life is really easy. If you just hit the play button, daydream. And after 20 hours, hit complete and get your certificate, I mean, you got a piece of paper, but that's about it. So the final bias here is that I actually am a technology professional. So a lot of the people that are going to be teaching you, right, they might be high school professors that did something else, high school instructors, they might have gone through a boot camp, did so well on the test, the boot camp then hired them. The important thing to understand for me is that I've been doing technology since 1996. I started off in the US Army doing electronic repair. I got my MCSE and something called NT 4.0 back in 2000. I was certified in Definity Systems. Right, if you know what Avaya is, I knew how to repair those back in the day. Basically, I've been doing technology for a long, long time. And not only have I been doing technology, I've also gone through the different generations of technology. When I graduated high school, you could make a lot of money repairing VCRs, right? I've been there for electronics repair and Windows NT, and then Active Directory coming out. I remember before Active Directory, when Voice over IP took over, when Wi-Fi, all of these different technologies have come down the pike. And one of the big things that I'll tell you is how you maintain being a technology professional over multiple decades is by learning how to be a technology professional. The certification isn't the most important thing. The technology itself isn't the most important thing. It's about being able to walk into an environment, understand the situation, understand the people that have a vested interest in whatever it is that you're trying to accomplish, figuring out what problem it is you're trying to solve, what resources you have in order to solve that problem, and then sitting down, writing out a plan, getting the approvals for the plan, and then working the plan. That's what it is to be a technology professional. It's not about, whatever current letters are behind your name. And so that's one of the ways that I try to teach these classes is it's trying to be not just, again, something like Python. This is an Introduction to Python series, not just about that, but also the overall mindset of how you do technology so that in 20 years, when you're going to whatever the new technology is in 20 years, you just yawn, sit there, probably watch me when I'm a 70-year-old guy talking about whatever the hell that thing is, and then just keep moving on with your career. So there is my bias as an instructor for Silicon Dojo and the basic bias of Silicon Dojo in general. It is important that you understand the bias of the instructor and the institution that you're going to whenever you're going to be learning any kind of subjects in technology, because what you're going to be taking away is essentially what the instructor has decided to present to you and the way they've presented it to you. If they're just simply trying to get you to pass a test, that is going to be a different type of education than somebody that's trying to teach you how to solve a problem. Now, there are reasons why you just want to test sometimes, so I'm not actually knocking that, but this is the kind of thing that you need to be thinking about from any program that you're going to be going into. So, if you're still interested in learning Introduction to Python, that gives you a view of where we're coming from, and I'm excited to teach this class with you.